All right, this is the video guide, the key for the stoichiometry mass to moles to mass problems. So looking at this, first thing you always have to do is balance, okay? If I want to balance the oxygens, I need to put let's see, a 2 here because I need a total of 6. Put a 3 here, that balances the oxygens. Put a 2 in front of the potassium chloride, that balances both potassium and chlorine. So first step, balance. Okay, now looking at this, we have 2.5 moles of potassium chlorate. All right, and we want to know how many grams of potassium chloride. Well, if we're going from moles to grams, it's going to be a two-step problem because the first thing I have to do is the mole ratio to go from potassium chlorate to potassium chloride. Then I need to use potassium chloride's molar mass. So this is going to be a two-step problem. So first thing, I notice that both these numbers are going to be 2, all right? Because so that's the mole ratio. Does that mean I can skip that step? I wouldn't, okay? It's not going to do anything in the end because you're going to end up multiplying, dividing by 2, but I would still place that step in there because you start skipping steps, you'll start skipping them when you're not supposed to. So let's see here. I'm going to put 2 moles potassium chlorate here, and on top, 2 moles potassium chloride. This way the moles potassium chlorate go away. I now know moles potassium chloride, but I didn't want moles, I wanted grams, so I need to know its molar mass. Every 1 mole of potassium chloride weighs 74.55 grams. Moles cancel. I'm ready to solve. I end up taking 2.5 times 74.55. I can skip this because I may end up multiplying and dividing, but it's good to show it. Okay, when you do that, your calculator poops out 186.375. We're going to have only 2 sig figs because of these two, so that's going to be 190 grams of potassium chloride. Okay, next one. We need to balance this guy. Let's see. Hydrogen, if I put a 2 here and a 3 here, that balances the hydrogen. That also fixed the nitrogen, so 1, 3, 2 are the coefficients. So I want to know how many moles of hydrogen are necessary to react with 50 grams of nitrogen. So this is just the reverse of what we just did. We're going to start out with the 50 grams. And so this time I need to do the molar mass of this first. So I want to put the moles of nitrogen. Whenever I'm doing molar mass, it's always 1 mole. Notice that's N2, it is not N. Okay, so when you look up nitrogen's mass of 14.01, you got to double it. Okay, because it's a formula, diatomic N2. Now I know moles of nitrogen. Now that I know moles of nitrogen, I can convert those to moles of hydrogen. According to the balanced formula, for every 1 I get 3. So 1 mole of nitrogen, and then the 3 moles of hydrogen from the balanced formula. Moles cancel. I have the unit I want. I'm ready to solve. I'm going to take 50 times 1, which you don't have to do, times 3, divided by 28.02. Your calculator is going to poop out 5.353319058. Okay, you're going to have 3 sig figs, so that's going to be 5.35. The unit, moles, the label, hydrogen. Okay, second part of that problem, I'm going to ask how many moles of ammonia are produced. Well, I tell you what, guys, you could use this answer to put it in here and start calculating, but I'm going to give you a hint. I wouldn't, because if you made a math error, if you fat fingered something on here, let's say you set it up perfectly, but you calculated it wrong, if you start with a wrong answer, it's going to make the next one wrong, guaranteed. So, first thing we need to do, I would start with the 50 grams once again. That's just me personally. You can try it starting with this answer. You should get the same one as long as the same result as long as you didn't make any errors. I'm going to start with the same thing. So I'm going to convert these to moles of nitrogen once again. 28.02 grams. Grams cancel. Now I know moles. And I'm going to go, instead of hydrogen this time, I'm just going to go to moles of ammonia. For every 1 mole of nitrogen, according to the balanced formula, there are 2 moles of NH3. Moles cancel. 50 times 2 divided by 28.02. And your calculator poops out this 3.568879372. Okay. Once again, I'm going to use 3 sig figs, 3.57 moles of ammonia. Okay, last set here. We got to balance this guy. Let's see. I'd probably start. Notice that I have 2 chlorines in 1, so if I flop a 2 there, that balances the chlorine. I'd put a 2 here for the silver. That also balances the nitrate, so 2, 1, 2, 1 are the coefficients. Wants to know how many grams of silver chloride produced from 5 moles of silver nitrate with excess barium chloride. That excess means there's all the barium chloride in the world. I'm not going to run out of it. So let's start out with what we know. 5 moles of silver nitrate. Okay. So since I already know moles, I can start with my mole ratio. Well, according to the balanced formula, I want to put the 2 moles of silver nitrate on the bottom so they cancel. And it looks like that forms 2 moles of silver chloride. Now that I know moles of silver chloride, I can convert that to mass using its molar mass. Whenever I'm doing moles and grams, it's always 1 mole. Okay, I only use the coefficients for the mole ratio part. So when it's molar mass, it's 1 mole. I add up silver and chlorine. It should be 143.32 grams. Moles cancel. I'm ready to solve. 5 times 143.32. I don't have to multiply and divide by 2. You get 716.6. You should only have 2 sig figs. 720 grams of silver chloride. Okay, last part. How much barium chloride? That question, I really should have said how many grams. Okay, so once again, I'd probably start with what I was given. 5 moles of silver nitrate. Okay, for every 2 moles of silver nitrate, mole ratio, there is only 1 mole of barium chloride. Moles cancel. Now, it's just the molar mass. For every 1 mole of barium chloride weighs 208.23 grams of barium chloride. Moles cancel. 5 times 208 divided by 2. My calculator tells me 520.575. I have to round that to 2 sig figs. 520 grams barium chloride.